right? And then store it back to out. Out here is R0, and compare with 0. There's a null character in this string. So repeat this process. As long as R2 is not 0, repeat this process, and finally return. Now cycle count. Okay, this is the program, and the logic you can trace it later. Okay. Now our interest is to how to optimize this code. Now if I compute how many clock cycles it will take for converting one single character into uppercase to lowercase, it is these many cycles. It will take 11 cycles. I can explain you this. So load, assume this is in the execute stage. It takes one cycle. Now when it is LDRB, you can observe LDRB. Since it is LDRB, sub V will be in the when this is in the execute stage. So it computes the address, this address. In LS1 stage it will read, and in LS2 also it will use. Now when this goes to the execute stage, it cannot start its execution until this finishes LS2. This is an execute and this is an LS2. Now second cycle and third cycles are stall cycles. That means second cycle this cannot do anything. It is waiting simply in the execute stage. Third cycle also it cannot do anything. It is simply waiting in the execute stage. In the fourth cycle it can execute. It executes, and this is executing in the fifth cycle. This is in the sixth cycle, and strb 7th cycle. And here there is no stall between these two because compare is not dependent on this. Now the strb, the destination register is this. Content of R2 it is writing to this memory location, and this is also reading R2 and this is also reading R2. It does. So compare is not writing. Compare is using for reading. So hence it can execute in clock cycle 8, and then BNE 9 clock cycle. And since it's a branch instruction, so the two flush cycles are also required, 10 and 11, 3 cycles. Now total 11 cycles are required for converting one single character from uppercase to lowercase. So similarly, now if I have written a string of 10 characters, 10 characters, and if I want to convert all this 10 characters in my string to lowercase, so 10 into 11. So 110 clock cycles are required. This is for one iteration I require 11 clock cycles. Now what we are doing here is load scheduling by preloading and unrolling. There are two techniques. This is taking 11 cycles per iteration, and this is too much. I want to reduce now. I want to optimize my code or improve the performance of my code. There are two techniques. One is preloading and unrolling. Now first we'll understand this preloading technique. Apply preload method to strlow. What I'm doing here is earlier, so we were loading it inside the loop here, strlower. Inside this loop we were doing. Now I'm preloading it. LDR. See, there is two loop. One, this is strlower is outer loop and loop is inner loop. I'm just loading the first character to see here, and then after loading, and this is what the logic I'm writing here. Observe here. And then so this loop, the current loop will preload the item for the next loop. This you can observe here. And we are using TU instead of compare. We are using TEQ. This TEQ already told you. I have compared TEQ with the compare also. LDR load not equal byte. So in this LDR we have the condition embedded, and this is the byte. And so the input to this first iteration of this loop is here. From here we are getting, and when this loop is getting executed, it is using the data from here, and when this current loop is executing, it prepares the data for the next loop. So this is next loop it will prepare, and then BNE move. So same thing. Only thing is we are preloading it. So the data required for the next iteration is preloaded in the previous iteration, and data required for the first iteration we are doing here. Now if I count the clock cycles for this, see, so this is not accounted right now because this is the statement which is written in order to preload the data required for the first iteration of this loop. Now here the loop will just count the clock cycle required by this loop, inner loop. So this is one cycle, compare is 2 cycle, and this is third cycle, strb 4 cycle, and since this is str byte, I got to check now whether you require a stall here. I don't require the stall because this is not dependent on this. This is also reading C and this is also reading C. Any number of instructions simultaneously read. Okay, and that is also getting executed in very next clock cycle. It is getting executed now, and this instruction is executing in 6th clock cycle. And BNE loop. So this checks C. BNE checks C, or it examines the 0 flag, and this is not dependent on this. This is not dependent on this. And again, if I say if I write some instruction and which requires C as the input, then I got to have 2 cycles stalls here. Right now, since this is not dependent on this, so cycle 7. And since this is a branch instruction, so clock cycle 8 is a flush cycle and clock cycle 9 is a when this is in the execute stage, we have 2 instructions which are already entered into the pipeline. So the next 2 sequential instruction entered into the pipeline, we got to remove them for them. 8 and 9 flush cycle, totally 3 cycles for the branch. Now 9 clock cycle. Now here to convert uppercase letter into lowercase letter, 9 clock cycles are required. If I write a string with 10 characters, to convert all the 10 characters from uppercase to lowercase, 10 into 9, 90 clock cycles are required. Here, 110 clock cycles are required. Here, it is happening in 90 clock cycles. Now, the preload improvement, speed improvement. So the original program was taking 11 clock cycles to convert one uppercase letter into lowercase letter. This was taking 11, and the scheduled program, the optimized code, this is the optimized code. Now it is taking 9 clock cycles to convert a single character from uppercase to lowercase. Now when I do 9 by 11, it is 1.22. Now what is this 1.22? This is speed up of the optimized code. The optimized code is 1.22 times more faster than the original code. That means this code is 1.22 times faster than this code. Next, now scheduling by unrolling. You understood how to scheduling or optimizing by using the concept of preload. That is loading the data required for the next iteration and the current iteration. That is what is preload. Now there is something called as unrolling, also loop unrolling. Now so in this loop, how many items we were converting? One item, only one item we were converting from uppercase to lowercase, and this loop was written. It's an override instruction, and this BNE is eating 2 cycles here to flush the pipeline on every iteration, and this we can avoid. Now what I can do now, if I have 10 characters, to convert from uppercase to lowercase. Now if I don't bother on the program length, now I can just skip this loop, remove this statement, and I can repeat this statement 10 times. I can repeat this statement 10 times. If I repeat this 10 times, and every time I'm avoiding BNE and repeating the same thing for 10 times, the only thing is the program length will increase. Now I'm avoiding these 2 cycles. That is what we are doing here now. We are unrolling. Now out RN0. Now I hope you know this already. RN is the register renaming, or assigning an alternate name to the register. Now what register is this? Register R0, I'm giving an alternate name out. Similarly R1, I'm giving an alternate name in. R2, I'm giving CA0, and for R3, I'm giving T, and for R12, I'm giving CA1, and R14, I'm giving CA2. And now here I have unrolled the loop for 3 times. See here. So the first element, the first source string. Let me take this example again. Now my source string, first character, just observe here. I am loading it into character 0, that is register R2, and the second one I am loading it into CA1, that is register 12. And I'm loading third one, I'm loading it into C, I'm loading it into R14. Now I'm subtracting. This is the logic. See, subtract, compare, add ls. So this is for converting the first character into from uppercase to lowercase, and this is converting the second character from uppercase to lowercase, and this is converting the third character from uppercase to lowercase. And these are the statements from here for pre-incrementing, incrementing it. This is for storing. here it is converted, and the converted lowercase letter you are storing it back. Now without using BNE, I avoided using BNE for 3 times. That means this loop is unrolled for 3 times, or the loop is unfolded for 3 times. Now I'm converting, I'm just computing the clock cycles here. See, load C1, and again second load, the LDRB, stalls are not required between these two, because this is not dependent on this. If this is dependent on this, 2 cycle stall is must here. Now loading the next character from into CA1 is not dependent on this. How do you say this is not dependent? Because this is a different register and this is a different register, and CA0 destination register is never used as input here, so hence it can execute in C2, and similarly C3, and then we have C4, subtract, compare, everything, and last one BNE instruction takes 3 cycles, C19, C20 and C21. Now 3 iterations, for 3 iterations, one loop we are doing 3 iterations. That means the loop is unrolled for 3 times, or the loop is unfolded for 3 times. Now 3, you're converting 3 characters into the lowercase letters using 21 clock cycle. Now to convert, that is what I mean, 3 iterations, 21 cycles, and 1 iteration is taking 7 cycle. To convert 1 character from uppercase to lowercase, to convert 3 character from uppercase to lowercase, you are using 21 cycle. Now to convert 1 character from uppercase to lowercase, how many cycles you are using? 7 cycle. In the first example it was 11 cycle, 11 you reduced to 9 cycle. Now in this example it is reduced to 7 cycles. Now the performance is 11 by 7. Now when I compare this code, which is unrolled for 3 times, with the original code which I showed you initially, which was taking 11 cycle for each iteration, so the performance of this program is 1.57 times more than the original code. I think you understood till here. We'll stop at this point. We'll continue the I need one more class to complete this writing ARM assembly code and optimizing, so one more class, 1 hour class I require. So the moment I finish that, so we can enter into the module 3. Yeah, thank you.